So in today's lesson, we will look at thermal energy transfer and the final type of transfer of thermal energy, thermal radiation. So looking back over our learning objectives, we've looked at conduction, we've looked at convection. Today we'll describe how energy transfer takes place using the process of radiation. So thermal radiation is the transfer of energy by something known as infrared waves, and you'll learn more about that next year. Okay, so radiation is the only type of heat transfer that can travel through a vacuum. Okay, remember that conduction and convection cannot occur through a vacuum, only radiation can. Okay, so gases tend to allow radiation better than liquids, and liquids allow radiation better than solids. So how do we actually detect this thermal radiation? So if you go out on a hot day, you can feel that your skin is warm. So where's that heat coming from? It's coming from the thermal radiation of the sun. And special cameras can actually detect this infrared radiation. So there is a link actually between thermal radiation and temperature. So all objects above negative 273 degrees Celsius, which we call absolute zero, give off this heat radiation, this thermal radiation. And the hotter you are, the more radiation you give off. Or the hotter the object, the more radiation it gives off. Okay, so here we have a hot object and it's giving out that heat radiation. It's radiating heat. Okay, and a cooler object still radiates heat, but not as much. And this is also, so how much heat energy is released or radiated is based on how much on surface and emission. Okay, so say we have a hot copper sheet. One side is nice and smooth, the other side is blackened. Okay, the color black. You put two hands against the sheet. Okay, you'll notice that the darker surface emits radiation better than the brighter surface. Okay? And the rough surface emits radiation better than the polished surface. In terms of absorption and reflection, if you have, for example, a electric heater and you stick a coin on it with candle wax on a shiny surface, and the same thing again, this time with a dull black surface, the dark surface will absorb the radiation best, okay, and the bright surface will reflect it best. And rough surfaces absorb radiation best, and polished surfaces reflect radiation best. And this is the reason, for example, on sporting events, people wear basically silvered surfaces or silver blankets in order to heat up. Okay, and it's the same reason why metal kettles are kind of a metallic shine to them, and that firefighters and a marathon runner use silver surfaces. Okay, because that means that the heat stays within and it doesn't radiate out. Okay, so just to summarize, here are the words. So pause the video now, fill in the gaps, and then come back to see if you've got the correct answers. Okay, so thermal radiation, also known as heat radiation, is how heat travels by electromagnetic waves. And radiation travels equally in all directions and most quickly through a vacuum, which has a speed of about 300,000 kilometers per second. All objects above absolute zero, minus 273 degrees Celsius, gives off thermal radiation, and hot, dark, and rough surfaces emit radiation best, and bright, smooth surfaces reflect radiation best.